Welcome to another episode of Kicked Up Chemistry with Professor Leonard. This is the third video in the three-part series on the introduction to the laboratory and different apparatus and glassware that you may be using in an introductory lab. So today what we're going to do is we're going to look at some specialized porcelain glassware, which has various different uses. We have the hot plate with the magnetic stir. This is an ultrasonic cleaner. And then let me come around and I'll give you a little tour of the other part. Here we have a laboratory convection oven. And here we have a laboratory vacuum oven. So we'll be looking at those as well today. So the first thing I have here is a mortar and pestle. This is the mortar, this is the pestle. This is for grinding up material. Now, the outside of this is glazed along with this, so it's very, very smooth. The end of the pestle and the inside of the mortar is left unglazed, so it's very, very rough. What this is used for is grinding up material. Now, a lot of people do not use a mortar and pestle correctly. They think that you're supposed to go down and pack it like that. That's not actually how you use a mortar and pestle. So, I have here just an antacid tablet. Hence, I'm not going to wear my goggles right now because I just have water and an antacid tablet. Again, if we were using anything else, I would have my personal protective equipment on, my goggles, gloves if needed, and of course I've got my lab coat on. So what you do for the mortar and pestle is you push down and twist and grind. So you're not really breaking up the material by pounding down on it. You're using the friction between the pestle and the mortar in order to grind it up to as fine of a powder as you need. Now it turns out that you never ever clean these things out all the way of the material you're trying to grind up. So what you want to do is you want to grind your material and then measure on the electronic balance how much of it you need. And just to give you an example of that, here I have my spatula. And I'm just going to transfer the ground up antacid tablet into my evaporating dish. Now, an evaporating dish is designed to be very high heat tolerant. So that way we can put it on this hot plate and it's not going to break, it's not going to crack. And if I go through and I try to get all that material out, you can see I got most of it, but there's still some of that pink colored antacid tablet that's stuck into the unglazed portion of the mortar, and some of it stuck on the end of the pestle. So you always want to measure after you grind it up. So that is the mortar and pestle. So again, the evaporating dish then, if we had water in here, for instance, or added to it and we wanted to evaporate it off, we could put it on a hot plate, turn the hot plate on, and evaporate it away. Now, this thing here is an ultrasonic cleaner. This is a very nice, large ultrasonic cleaner. We can use it for cleaning various glassware. So I can take this mortar and pestle, you get that last little bit out of there. Probably a better way to do that first would be to add a little bit of vinegar to it because it's an antacid. Vinegar is acetic acid, 5% solution of acetic acid. It's going to dissolve it, and then we want to wash it in a laboratory solution. So we would take it, we would put it into our solution, turn it on, and the ultrasonic cleaner would vibrate and get to all those little grooves that's inside of the unglazed portion of the ceramic and clean it out really, really well. Now, another thing that the ultrasonic cleaner is really useful for is degassing a solution. Whenever you have a solution, you get air or whatever other gas from a byproduct of a chemical reaction dissolved into it. What you could do is you can leave this empty, take your solution, put it into the ultrasonic cleaner, turn it on. Those ultrasound waves will vibrate it, getting all those bubbles to outgas out of your solution and hence making it a pure solution, and degasses the solution then. All right, now that I cleaned up the lab bench here a little bit, we're going to concentrate on the hot plate with the magnetic stir. But I did want to mention a couple of useful things that are very helpful in the lab, especially when you have a laboratory notebook. The first is a chemical stencil. So when you have to draw the diagrams of all these different apparatuses in the lab, and that's one of the things in lab reports, a lot of times you'll have to draw a diagram of it. This makes it a lot easier than trying to freehand draw it, and it makes it a lot quicker. In addition to a stencil, you're going to want a ruler as well. This is especially useful when you are doing thin layer chromatography, which is often called TLC. Now, with thin layer chromatography, you have these plates that are coated with an adsorbent material. You're going to spot it, you're going to put it into a solvent, it's going to wick up the plate, taking some of the dot, the solute, along with it, or it'll separate different impurities out of your mixture, and then you can analyze it. One way you do that is you measure the distance that the solvent moved, distance that the spot moved, and that'll give you something called the RF. So very important that you have a good ruler as well. So of course this is the hot plate, and safety is the utmost thing that we always want to stress in the lab. Hence that's why if we're using anything besides water and the antacid tablet, you want to make sure you have your goggles on. Always assume glassware is hot. Hot and cold glassware look the same. You don't want to heat a dry beaker also. So what I'm going to do is I'm just going to take some water. Got a water bottle here. We'll put it into the beaker. Again, if you recall, this is called a Berzelius beaker. And turn the hot plate on. Now this one is kind of nice because it actually has on here the temperature of that you could set it, the hot plate at. A lot of other hot plates don't have a digital readout. They just have 1 through 10 typically on the knob there, and you have to kind of adjust it to figure out how fast or it's going to heat up and how hot it's going to get. Now, as that heats up, another function of this, it says here stir. So I have a magnetic stir bar that's Teflon coated. We simply drop that into there and turn it on. Let me zoom in here for you. And so now you can see that besides the hot plate getting hot, it's stirring around in there as well. And you can adjust the speed of the stir bar. And it tells you the revolutions on there, RPMs. And we have ourselves a little tornado. Now that's pretty cool in itself. Normally what I would do to demonstrate this is I would also put a little food coloring in there so you could see it a little bit better. Now, I don't have any food coloring handy, but I do have something else. Something to stir a little bit easier. I have here my handy beaker mug, so it's got a handle on the side there. This is actually for drinking out of, not for labware. And even though we never eat or drink in the laboratory, boy, I really could use some caffeine because, you know, this video is taking quite a bit of editing in there. So I got to keep going. Now the directions on the instant coffee say to 6 ounces of water, add 1 rounded teaspoon of coffee. So 6 ounces is 177 milliliters. So I'm going to put, there's 150, halfway in between the 150 and the 200 should be about 175. So that's pretty close. And then I'm going to go ahead and turn it on so it starts getting hot. Now I have a brand new, never been out of the package magnetic stirrer, so it's nice and clean, never been used. So I'm going to open that up. I'm going to put that in, and I'm going to start stirring in around. And there it's stirring. Sometimes, if you get it stirring too fast, it jumps around like that. So then you just want to slow it down. 1 teaspoon, rounded teaspoon of coffee into my beaker. If I turn it up just a little bit, in just a couple of minutes, my coffee will be ready. Alright, so now that my coffee is ready, it's nice and hot, I'm just going to take that off the hot plate here. And I'm going to set that to the side because, again, we're not really supposed to eat or drink in the laboratory. So let me clean up this a little bit, and then we'll go on with the convection oven. Now, this is a laboratory convection oven, very similar to a convection oven that you might find in your house, but it's just designed to dry out samples that you may have a solvent, you precipitated it, you filtered it out, and you want to drive all that solvent off. So you can put it into the oven. It has convection, so it helps dry it out. And you may ask, hey, how come it's on the floor, not up on the lab bench? Well, as you can tell, with all the COVID-19 going around, I'm not allowed to film in my actual lab. So I kind of had to set up everything that I could here. And to be honest, this thing is really big, it's really heavy, and I don't have any tables that it would actually fit on. So it's just sitting down here on the floor, which is perfectly fine. It's a concrete floor, so that way it's safe, nice, resistant, flame resistant, heat resistant surface. So let's take a look inside here. And of course, we always want to make sure that we follow our proper personal protection equipment. So I'm putting on heat resistant gloves, and we'll open up the oven and take a look inside. And what the heck? Oh, I completely forgot that when I was making my coffee that I had some pie to go along with it as well. Well, we'll just put that over here on the side because, again, we can't have any food or drink in the laboratory. I don't know what that pie was doing in there. And you can see it looks just like any other oven. This is a laboratory vacuum oven. In addition to heating up a sample to drive off the solvent, up here this tube is connected to a vacuum pump, which is down over there on the floor, and we can read the vacuum gauge. Because what will happen is that at the temperature... Now what we have here is a laboratory vacuum oven. In addition to heating up the sample to drive off the solvent, we can also put it underneath a lower pressure. Because what will happen is when you decrease the pressure on top of a liquid, it's actually going to make it boil at a lower temperature. And this tube up here is connected to a vacuum pump, a very good vacuum pump down on the floor. And we can read the vacuum gauge here. We can set the top temperature. So right now it's set at 73 degrees Celsius. Now, remember that coffee that I made? I really hate to waste things. Everything, is green nowadays, green chemistry. And so I really want to save it for later, but I don't want it to spill all over. So if you've ever taken coffee and left it on a coffee pot for too long on the burner, it evaporates and it just basically turns to a sludge. Well, I wonder what would happen if we set it at a lower temperature, well below the boiling point of water at 100 degrees Celsius, and then we put it under a vacuum. Would that evaporate the water and give me the crystals back of the instant coffee that I put in there? I wonder. Let's find out. So I'll open up the door. It's got a lock over here on the side. I'll take my laboratory safe beaker mug and set it in there. Now again, this is only at 73 degrees Celsius. It's not at the boiling point of water, so it's not going to evaporate or boil all of it away and leave a sludge at the bottom, I hope. Now I'm going to turn on the vacuum pump. It may get a little bit loud, so I'll try to talk over it. I have to turn the knob here for the vent back off, so that way it seals up to the vacuum. And then we can see that it's set at 72 degrees Celsius, and the vacuum is indeed going up. So we'll just give it about 30 seconds or so here, and we'll see how much of a vacuum that we can actually get. It's been about 5 minutes now, and we've got a really good vacuum going on in here. As we can see, it's at negative 27.6. And if we can see inside what the coffee's doing, look at that. The foam is going all over. It's boiling well below the boiling point of water. So decreasing the pressure over the top has made it so that way it's actually boiling. Well, I'm going to go ahead and turn off the vacuum pump. And we'll seal the vacuum in there. So I went ahead and I turned off the vacuum pump and I sealed it, so there's still a vacuum going on in there. So it was making kind of a mess, as you could see. And so I turned off the pump. I'm going to leave the temperature on, and it was kind of noisy. So what I'm going to do is I'm going to set my phone here for the timer on it for 2 hours. So timer, set for 2 hours, and start. And I'm going to come back in 2 hours and see what my instant coffee looks like in there. Oh, I dozed off there. My 2 hours is up. So turn that off. There we go. And, let's check this. Okay, let's turn off our oven. We still had a vacuum going on in there. We got to vent it because it's sealed up. And so what I have to do is open up the vent here that allows air back into the oven. So we're repressurizing it. It was at a low pressure. Now we're putting it back to a normal pressure. We have to wait until it's completely depressurized before we can open it up. It's just like an airlock on a spaceship. All right, now that our pressure is decreased enough, I can go ahead and unlock the oven door. Whoa! Would you look at that? All the water's gone, and we have our instant coffee back. Isn't that something? Now, in actuality, that's not how they make the freeze-dried or instant coffee. It's called freeze-dried because they take the liquid coffee, they freeze it, they reduce the pressure in an oven, very similar to this one, and the water goes directly from being a solid to a gas, sort of sublimes away, hence leaving the dried coffee, and you can reconstitute it by adding water. Well, that's it for our 3-part series on Introduction to the Laboratory and Laboratory Equipment. If you haven't already watched part 1 and part 2, I would strongly suggest that you watch those as well. And what I really hope, though, is that you learn somewhat about the different devices and apparatuses that are used in the chemistry laboratory. Please click that like button and subscribe. I have a lot more video ideas on demonstrations that I'm going to be uploading pretty soon here once I get them made. Needed to get this Introductory to the Laboratory series done first, and then we're really going to kick it up, hence the name of the channel, Kicked Up Chemistry. So stay tuned, click that subscribe button so you're notified when new videos are uploaded. Thanks for watching.